Hello students, welcome back to the channel. And yes, today we are going to study structure of atoms, and this is the lecture number 2. So I hope you have read the first lecture or watched the first lecture, and if you're not done, then please do it now because it's really important. Otherwise you will not understand this lecture. So please do that. And yes, what I have taught in the previous lecture, I taught all about the cathode rays and the anode rays, how it was discovered, and all about the discharge tube experiments. So yes, do read that. Okay, now let's start this lecture. Okay, so yes, in this lecture I will tell you all about the subatomic particles. So actually subatomic particles are also known as fundamental particles. So first let me clear out the basic things. What is the subatomic particles? What are the subatomic particles? They are just what is found inside an atom, that is known as the subatomic particles. Like previous like there were perceptions that atoms are the last divisible particle, and it is not further divisible. So when we divide any matter, and that's the last which is like divided. So further atom cannot be divided, but later scientists found that no, inside the atoms also there are a lot of particles. So these are known as subatomic particles. So now as you can see on the slide that I have divided into two parts, that is, one is stable fundamental particles and another one is the unstable fundamental particles. So you might be thinking, hey, what is these? Because it is not mentioned in your NCERT book. But this is important. Okay, but what is this? See, how we define this criteria. When we take an atom and when we see कि yes, this suppose like I might be sure कि you know कि what is electrons, protons and neutrons. बाकी सब थोड़ा सा मतलब शायद किसी को लग सकता है, बहुत सारे लोग तो जानते ही होंगे, बट कुछ लोग शायद नहीं जानते होंगे कि ये सब बाकी सारा क्या है, like positron and proton. Yes, I will discuss it now, but yes, the problem is that what is when these subatomic particles are found inside the atoms, so they are stable. All the fundamental particles inside an atom is stable. But the problem is where that when we take out of the atom, then the stability of like some subatomic particles is not there. So they are known as unstable. For example, like neutrons. So they are completely stable. They are only stable in fact inside the atoms. But when we take out and we make it free, then that is completely unstable. And it's kind of like the average life of that neutron will be 17 minutes only. So that's what. So for that reason I have divided in this criteria, and you can see this thing in the stable fundamental particles, it comes, the proton comes, electron, positron, antiproton and neutrino comes. And in the unstable fundamental particles, mesons and neutrons comes. So that's it. Now let's move on to the next slide. Yes, so let us discuss all about the electrons. So electrons, I think you know this thing that it is negative charge. Okay, so if you have seen the electrons, like it is the negative charge one, and also we denote it kind of this. See, we take N and then we like put this kind of into minus, the charge. Let me just talk and then I'll tell you this thing. See, negligible mass means what? The mass is kind of very little, like it is near to zero. For that reason, when we indicate that, also we write like this, elect E, and here we give the symbol minus, negative, and here we put 0, because the mass is like near to 0, but it's not equal to 0. But yes, we just indicate it like that. And also it is hence it is known as unit negative charge particle having negligible mass. I think that you might be familiar with the term that atom is something like this, and like inside this there's a center part where protons and neutrons are present and electrons are surrounded by it. If you don't know, then don't worry, we are going to study these things in the further lectures where I will teach you the models and all. So don't worry, but yes, just remember this thing. For the reason what we consider the mass of the protons and neutrons are considered because they are in the middle part, and for that reason have to specify this thing, that yes, inside an atom the mass is there in the middle or the center of the atom, but all around it is just very negligible mass, which is not equal to 0, but it's near to 0. That's what I want to tell. Okay, now let's move on. Yes, it was discovered by J.J. Thomson and he named it as catron. So yes, J.J. Thomson have discovered electron first, but he did not name it as electron that we know today. He actually named it as catron, but the name electron was given by Stoney. Okay, so yes, this happens a lot of times in your science, in physics, chemistry, and also in bio a lot of times, that what happens, the names are like somebody have discovered, some have saw it, like, and some have given another name, and another scientist came and he gave the name which we know it by today. So a lot of scientists we have to remember. But yes, the questions don't used to come a lot, but sometimes it might come. So for that, you just know this thing, because these are just so basic. Okay, next is the electron is the lightest fundamental particle, as I have mentioned it before also, that yes, all the electrons around the middle part or the center part of the atom. So for that reason, this is known as the, all those parts are, it doesn't contain any mass, very less amount of mass. So for the reason, that's the thing, only the lightest is the lightest fundamental particle. And then charge of the electron was calculated by Millikan. Okay, this I will describe you later in this lecture only, but yes, let's move on to the next slides. Now, charge to mass ratio of electrons. So when this J.J. Thomson, the scientist, when he started discovering the electron, then he thought of experimenting, he thought of doing a lot of things with that, so that he could get a lot of more ideas. So he started doing in 1997, as you can see, it is from your NCERT lines. So you can also prefer to your book. You can look at your book, and yes. It was measured, J.J. Thomson measured the ratio of electrical charge, or E, and mass of the electron, that is M, and actually see, let me just write it again. See, this was M, and then near, so the subscript, which is E. Okay, so like this. Actually here typing mistakes are not there, so consider those points. And yes, it will be better if you look at your NCERT books. So by using cathode ray tube and applying electrical and magnetic field perpendicularly to each other, as well as to the path of electrons. So what it did, see, as you can see in the diagram also, here see, here in the diagram, this is the north pole, this is the south pole. What it means, this is the magnetic field, and here is the positive and here a negative, this is the electric field. So he applied this perpendicularly, see, like this, perpendicularly. He kept both the fields perpendicular to each other, and he tried, see, he just took a cathode tube and he tried to put the cathode rays. So he looked, what will be, he observed. What he observed, he experimented only this thing, that what will happen to the rays, where it will go when it will strike to these things. Okay, so now let's read this thing. When only electric field is applied, the electrons deviate from the path and it hit the cathode ray tube at point A, and similarly when the only magnetic field is applied, then it went to the C. Okay, let me explain you this thing. See, when he applied only electric field, then what happened, means he just kept the magnetic field 0 and he only applied the electric field, then what happened, the this ray, cathode ray, it just went like this to this side, and this A point, this is the showing of the electric field, what happened to that. And when he only applied the magnetic field, then it moved like this. Okay, can anybody guess how this happened? See, as we know, these electrons or the cathode rays are electrons, which is negative charge. So obviously it will move this side, because it is the positive charge. Here is the positive pole of the of this electric field, and here is the negative pole. So it will obviously go this side, and in the magnetic field it is going like this. But another surprising point came when he tried to balance the both. So he tried to balance both, so magnetic field and the electric field. Then what happened? It just went straight. As you can see in the diagram, it went straight and hit the point at the B. So that's what is mentioned here. All in your NCERT also is mentioned. I have also written here in the screen, as you can see. Now Thomson argued that the amount of deviation of the particles from the path in the presence of electrical or magnetic field depends upon, now he understood where it is depending. So it depends upon the magnitude of the negative charge, and also it depended upon the mass of the particle, and also on the strength of the electrical or magnetic field. So so it depended upon these points. Now I'll say when how it is depending upon. So it is inversely proportional, it is directly proportional. What is happening to it? So now he experimented, he did a lot of things to understand this thing. So when first point, look at the first point. So when we are getting the magnitude of the negative charge, so when he is making the magnitude great, so what is happening is that the charge of the particle is also getting more, and then the charge of the particle with the electric or the interaction is getting more. So when he is increasing the magnitude of the negative charge, so the interaction with the electric or magnetic field is getting more. So it is directly proportional to the magnitude of the negative charge. Next is the mass of the particle. So mass of the particle. Now when he is getting, this is another thing. When he is making the lighter, when he is taking light particles, then more deflection it is showing. So it means it is inversely proportional to the mass of the particle. So when very light particles, if he is taking, then more deviation is happening. So that's the thing. Then strength of the electric field or the magnetic field. So what is happening? The deflections of the electrons from its original path increases with the increase of the voltage of the strength. So it is like that only in the same case. That is also directly proportional. So when he is increasing the strength of the magnetic or the electrical field, the deflections is becoming more. And that's very that's no doubt will happen, I hope, in this. Now let me just show you all the rest of the things that is left here. See, by carrying out accurate measurements, the amount of deflections observed by the electrons or the magnetic field strength or the magnetic field strength, Thomson was able to determine the value. Now by understanding all these stuffs that I have explained you, he understood yes, due to this thing only we can calculate something, which is the E by M ratio. E means what? E means the charge, and M is the mass. So charge to mass ratio he calculated, which came to be around 1.7588820 into 10 to the power 11, that is to the power 11 coulomb per kg. That's what. And yes, this is another thing is that when we take the calculations, calculations will also come in this chapter. So you just consider 1.75. Don't consider these all the whole numbers, otherwise you will get confused. And I don't know, you have to remember a lot of things also. So don't remember just a single thing so that you will forget rest of the things. So remember this for the calculation, that 1.75. Okay, you can use that in your calculations and the answer will be correct. Okay. So now let's move on to the next page, that is charge on the electron. So you might be knowing this thing, R.A. Millikan was one scientist who did this oil drop experiment, which was very famous that time. So he did that oil drop experiment and he determined the charge on the electrons. Okay, so when he found the charge on the electrons, then obviously the mass will be very easily calculated, na? Because J.J. Thomson already found out the charge to mass ratio. So when he calculated the when he found out the charge of the electron, then the mass is only what? That's so easy now. Now that can be calculated easily by some like multiplications and divisions. So that's what. So he also played a great role for getting the charge of the electron. So he did this oil drop experiment. So he devised a method which was known as oil drop experiment during 1906 to 14 to determine the charge on the electron, and he found the charge on the electron what? that is minus 1.6 into 10 to the power minus 19 coulombs. Yes, that's a very easy number also to remember. Okay, and yes, now presently, but yes, when now machines came, yes, the advanced machines have detected that the present accepted value, which is now accepted also, which is, that is, electrical charge is 1.60 to 176 into 10 to the power minus 19. So he is completely close to that value. But yes, I know ki a lot of like which is known as a lot of perceptions, like you can see this thing ki itna chota values have there, that yes, that's correct. Okay, because, and also another thing is that when we take the questions, when we practice the questions or the numericals on this chapter, we take it 1.6 also. Okay, so he was correct, we can say he was correct. But yes, the modern machines have calculated, and very precisely the machines are calculating. But yes, he did it, and that's great. Now we can also determine, by combining these results, the mass. How we can detect? See, here I have written mass is equal to E by M ratio. So like this. Okay, let me do it. See, we can calculate the mass as E by M ratio. Okay, like this. And yes, we can get the value. E means the charge. Okay, charge by M. So like that what will happen? See, this will happen कि ये जो E by E है ये कट जाएगा, and then M will be at the top. So that's only the same thing. So if we'll calculate the values of these, so we can find the M. So we can also write it like this now. So if we'll write the charge, and also we'll write the charge to mass ratio, which is 1.75. So we can get the answer. Okay, which is this, see, 9.1094 into 10 to the power minus 31 kgs. Okay, now let's move on to the next slide. That is the protons. So protons was discovered by Eugene Goldstein, and he named it as proton. Like, the name proton was not given by the Eugene Goldstein, it was given by Rutherford. Okay, same type of things. And the charge of proton, see, charge of proton is kind of the plus. See, we have, you know ki, yes, the charge of electron is what now? Minus 1.6 into 10 to the power minus 19 coulombs. But in the case of charge of proton will be plus 1.6 into 10 to the power minus 19 coulombs. So simple. Then mass of the proton, remember this point, that mass of the proton that I have said na, electron has very negligible mass, and yes, mass of the proton is 1837 times mass of the electron. So it is more than, means 1837 times, okay, 1837 times more than the electron. So that's what. Okay, now let's move on to the next slide. So this is the neutron, and charged or neutral particle having unit mass. So what is this? This is, sorry, it's not uncharged. Sorry, this typing mistake have happened. This is not this is uncharged, not this is uncharged. Okay, uncharged. Okay, so this is the uncharged or neutral particle. So it is not charged at all, and its unit mass is more actually. See, it was discovered by James Chadwick. And okay, this point you need to know ki yes, when beryllium was bombarded with alpha particles, neutron was discovered. So now when we just okay, let me just do you want the equation? Let me just write it so that that will be also clear. Okay, so when we take the beryllium, let me just move on to the blank page. Yes, so when we take beryllium, Be4, okay, this is, and yes, we take alpha particles. Alpha particles is what? 2, 4. Okay, so when we take these two, what have happened by this? When we bombarded this beryllium with alpha particles, carbon first came, carbon 612, and along with that neutrons came. Means neutrons, we discovered neutrons by that. Okay, so which is obviously because the it doesn't have any charge, but it has mass, which is equal to 1, you can say. Yes, more decimals are also joined there, but yes, it's equal to 1. So this is the kind of the equation. Okay, I hope it's clear now. Yep. Okay, so it is the heaviest fundamental particle. Also, the neutron is the heaviest fundamental particle, and the procium, in procium of hydrogens are of 3 types. So from that, procium is in the neutron is not present actually there. Okay, and it is the best projectile particle due to chargeless. So neutrons are also used for the like the nuclear reactions. Neutrons are used for that also. So I hope this is completely clear now. Now let's move on to the next slide. Now I will teach you the less important these things, like these are the positron, antiproton. So they're less important, but yes, still you need to know this thing. Because कभी भी कोई भी क्वेश्चन आ सकता है ना, तो क्यों चांस ले हम. Okay, if you want to write, then that's great. Please write it down. Now positron is what? This is a positive charge electron. So the it is a positive charge electron. Okay, so that kind of thing. Now it was discovered by Anderson, and if a particle mass has not changed but the charge is reduced, if the mass is not changed but the charge is reduced, then that means particle is then the released particle is the positron. Okay, by that we can understand this thing, right? And the mass is same as electron, so it means it is a very little amount of charge mass is present, but the charge is same as proton. By this point I hope you are clear now. ये सब थोड़ा थोड़ा आपको डाउट लग रहा होगा, पर ये लास्ट पॉइंट तक क्लियर हो जाएगा होगा कि पॉजिट्रॉन क्या है. Positron means mass is same as electron. Okay, it means very negligible mass, but the charge is equal to the proton. Okay, now the next is the antiproton. Antiproton is what? Negative charge proton. So it was discovered by Sagar. So this is what a negative charge proton means. Its mass is same as proton. The mass is like more, it is not negligible or not zero, kind of not that. So mass is present and it is same as proton, but its charge is same as electron. So charge is negative, it means. Okay. Next is the neutrino. Neutrino is the chargeless, massless particle. So it was discovered by Pauling. So it doesn't have any charge, or it doesn't have any mass. So it's a chargeless and massless particle. Okay. And the last one is the mesons, which is the unstable one. I hope you remember that thing, that I have put the mesons into the category of the unstable fundamental particles. So this was discovered by the Japanese scientist Yukawa, and proton and neutron can be converted into mesons. Okay, this can happen, and the mass is like 200 times more than the electron, and charge can positive, negative or zero. So this is a very different kind of a particle, and it is also instantaneous, which I have not mentioned in this. So yes, remember that thing, or you can also, if you're writing, then please write it down, that mesons are instantaneous particles. Okay, and the mass is 200 times more than the electron. So imagine the mass is very great. Okay, and the charge can be positive, it can be negative, or it can be zero. So for the reason only, in the above points that I have mentioned here, that proton and neutron can get converted into mesons. So that means that only. Okay, and modern stability is due to the mesons only. Okay, so this was discovered very later. So I hope it is, I think, completed the things. Okay, so all I have now taught you. I hope you don't have any doubts, but yes, if you have any doubt, please write it on the comment box so that I can take it on the next class. Okay, so simple. So thank you so much for watching this lecture. And yes, next class we will talk about all the models, okay, that scientists have done, or and also otherwise I will talk about all the the properties and all. Okay, I'll think what will be easier for you. Please comment down that also. Okay, next class what we'll do. Okay, so okay, now thank you for watching this lecture, and please subscribe to the channel, and I have promised you that I will upload lectures regularly. Yes, I'm doing so that only. So please subscribe to the channel, and please press on the bell notification so that you will stay updated. Thank you so much.